everyone. This is the fifth video from a series of videos discussing why dawn in Indonesia occurs too early. Please follow the previous videos to understand this video. We are from the Islamic Science Research Network, Hamka Muhammadiyah University in Jakarta. This series of videos is a summary of a book in Indonesian entitled The Evaluation of Dawn and Isha Times. Science, Technology and Sharia Perspectives, which was published on January 5, 2018. English and Arabic editions of the book are being prepared. To order the published book in Indonesian, please contact Hamka Press, phone or WhatsApp, +62 838 7266 8742. The title of this presentation is Light Pollution Does Not Delay the Presence of Dawn. In a collaboration with the youth wing of the Muhammadiyah Regional Administration in Yogyakarta, ISRN conducted the collection of the astronomical data at two different locations, namely Crackle Beach and Panggik Hill. They are apart by some 55 kilometers as shown in the Google Earth map. The collected data from these two locations demonstrate a good case whereby heavy light pollution does not really delay the presence of the dawn. For this, we highly appreciate Anto and OKY who had helped us during our two-day mission in Yogya. We used an SQM for determining the exact timing of the presence of the dawn, whilst a DSLR camera Nikon D5100 to confirm the presence of the dawn. Nikon D5100 produces a very high-resolution image with 3,264 rows and 4,928 columns, or a total of more than 16 million pixels per frame. When we started the data acquisition at Crackle Beach on May 5, 2018, it was coincident with the 19th day of the Islamic calendar of Shaban, or only 4 days after the full moon. The moon's characteristics were as follows. The status of the moon phase was a waning gibbous moon, where the illuminated moon was in the process of reducing from the full moon condition. In the Hijri calendar, it was the 19th day of Shaban 1439. The moon rose at 21 hours 0 minutes and 20 seconds and set at 9 hours 2 minutes and 35 seconds on May 5, 2018. The moon reached its culmination point at 2 hours 37 minutes and 13 seconds by the time of the data acquisition. The illuminated part of the moon was 78.56%. This image shows a clear and high-quality view of the southwest direction. According to the moon's ephemeris, the moon latitude was +62 degrees, and moon azimuth was 241 degrees. This Google Map photo shows the position of our instrument from the nearby beach. The SQM data for May 5, 2018. On May 5, 2018, we started the SQM data collection at 4 hours 18 minutes and 10 seconds hours or 2 minutes before the official dawn at 4:20 a.m. until 5 hours 39 minutes and 38 seconds a.m. or about the sunrise time. With the 3-second temporal resolution, there were more than 1,600 SQM data collected on that day. The official Fajr prayer call happened at 4:22 as shown by this blue line, which obviously was too early. Meanwhile, the estimated dawn occurred about 14 minutes later at 4 hours 34 minutes and 16 seconds as shown by the red line. The detailed mathematical modeling, which is based on the 4th-degree polynomial, is shown in this slide. The graph shows an almost perfect match between the physical SQM data with the polynomial model, which gave the root mean square error of 0.03 magnitudes. We then used the Nikon D5100 images to verify the presence of the SQM dawn at 4 hours 34 minutes and 16 seconds using the histogram and visual analyses of the available images. Histogram analysis of the Nikon D5100 images. Let's put histogram of the image taken at 4 hours 25 minutes and 17 seconds as a benchmark on the left. It is therefore the histogram of the image taken about 5 minutes after the official dawn at 4 hours 20 minutes and 8 seconds. On the right, We put the histogram of the image taken at 4 hours 33 minutes and 2 seconds, or about a minute before the SQM's estimated dawn. We cannot differentiate these two histograms, which proves that it is impossible that the dawn occurred between these two images. Later we put the benchmark remain on the left while on the right. We put the histogram of the image taken at 4 hours 36 minutes and 2 seconds, or about 2 minutes after the SQM's dawn. Now, we can see the difference, although it might not be too obvious for many. The number of pixels having the grayscale value of 20, for example, has reduced from 470,000 on the left to 440,000 pixels on the right. Consequently, this has made the number of brighter pixels having the grayscale value larger than 50 increase because the number of pixels in an image remains constant. In other words, the histogram on the right actually spreads wider. The spread is more apparent when we compare the benchmark histogram on the left and the histogram of the image taken at 4 hours 41 minutes and 2 seconds on the right, or about 7 minutes after the SQM's dawn. Visual analysis of the Nikon D5100 images. In spite of the fact that light pollution didn't affect the histogram analysis, as shown above, it seemed to have an effect on some image processing techniques, namely image adjustment and edge detection. First, we put the original image taken at 4 hours 25 minutes and 17 seconds on the left as a benchmark, or about 5 minutes after the official dawn. On the right, we put the image taken at 4 hours 36 minutes and 2 seconds, or about 2 minutes after the SQM's dawn at 4 hours 34 minutes and 16 seconds. Actually, the spreading red hue began to occur behind the background hill, although visually, it is not too distinguishable. The difference is more apparent when we compare the benchmark image on the left with the image taken at 4 hours 41 minutes and 2 seconds on the right. The distinguishable spreading red hue from behind the hill showed the presence of dawn. Despite visual analysis works sufficiently well as shown in this slide, one should remember that the SQM has been able to detect the dawn at 4 hours 34 minutes and 16 seconds. Therefore, the visual appearance of the dawn was actually 7 minutes late. It further proves that the SQM sensor is much more sensitive than the naked eyes. The SQM data for May 6, 2018. On May 6, 2016, we moved the data acquisition further northwest to Pangak Hill. Also in a collaboration with the youth wing of Muhammadiyah Regional Administration in Yogyakarta. When we started the data acquisition, it was coincident with the 20th day of the Islamic month of Shaban. The moon's characteristics were as follows. The status of the moon phase was a waning gibbous moon, where the illuminated moon was in the process of reducing from the full moon condition. In the Hijri calendar, it was the 20th day of Shaban 1439. The moon rose at 21 hours 48 minutes and 50 seconds and set at 9 hours 51 minutes and 26 seconds on May 6, 2018. The moon reached its culmination point at 3 hours 25 minutes and 52 seconds by the time of the data acquisition. The illuminated part of the moon was 70.34%, or about 8% lesser than the previous day. According to the moon's ephemeris, the moon latitude was plus 71 degrees and moon azimuth was 227 degrees. Unlike the SQM data on May 5th, a polynomial model didn't work for the SQM data of May 6th because the SQM data tends to decline since 4:20 a.m. We then applied the moving slope analysis using 3 different windows 3, 5, and 7 data. Within the selected window, we were basically looking for a point beyond which the slopes of the line consistently to be negative, with which we could estimate that the average real dawn occurred at 4 hours 40 minutes and 10 seconds, or at the dip of minus 15.1 degrees. Histogram analysis. To verify the SQM estimated dawn, we analyzed the histogram of the images we collected using our Nikon D5100. First, we put the histogram of the image taken at 4 hours 20 minutes and 50 seconds as a benchmark on the left. It was therefore about the instance of the occurrence of the official dawn according to the government of Indonesia. On the right, we put the histogram of the image taken at 4 hours 25 minutes and 0 seconds, or about 15 minutes before the SQM's dawn. We cannot identify any distinguishable difference between these two figures. The difference becomes distinguishable when we compare the benchmark histogram on the left with the histogram of the image taken at 4 hours 41 minutes and 0 seconds, or about a minute after the SQM's dawn. This histogram confirms the presence of the real dawn at 4 hours 40 minutes and 10 seconds. Edge detection analysis. For the edge detection, we also put the delineated edge of the image taken at 4 hours 20 minutes and 50 seconds on the left, and the delineated edge of the image taken at 4 hours 25 minutes and 0 seconds on the right. Again, we cannot see the difference between the delineated images' details. It simply means that it is impossible that the dawn occurred between these two images. The delineated details become apparent when we compare the benchmark edge detection on the left with the edge detection of the image taken at 4 hours 41 minutes and 0 seconds, which is only a minute after the SQM's dawn. This confirms the occurrence of the real dawn at 4 hours 40 minutes and 10 seconds as detected by the SQM sensor. Visual analysis of the original images. Visual analysis of the original images further verifies the presence of the dawn detected by the SQM. We cannot witness any difference between the image taken at 4 hours 20 minutes and 50 seconds on the left and that if taken at 4 hours 25 minutes and 0 seconds. However, the spread of red hue is distinguishable from behind the hill when we look at the original image taken at 4:41:00. The presence of the dawn as detected by the SQM sensor at 4 hours 40 minutes and 10 seconds is therefore undeniable. Conclusion. There is no scientific evidence that the dawn had appeared at -20° dip. A DSLR camera is ideal for the verification task to confirm the presence of the dawn. However, the SQM has a much more sensitive sensor than the Nikon D5100 camera. Despite heavy light pollution due to the waning gibbous moon, the estimated dips on May 5th and 6th, 2018 are much higher than the national average of -13.3 degrees. Therefore, light pollution does not delay the presence of dawn. ISRN will use a DSLR camera as standard equipment to verify the presence of dawn. Thanks for watching.